Hello and good afternoon, CSI 157 Section 844 students for the first of two mini 8-week sessions during the fall 2014 semester at Anne Arundel Community College. I had a number of students request that a video be done up to take a look at PacketTracer activity 8.3.2.6, and so that's going to go ahead and be the PacketTracer activity for today. All right, so let's go ahead and jump right in. Let's take a look on PC1, and we're going to pull up the desktop tab here. Let me make this window a little larger for you right now. And so let's take a look at the command prompt, and it wants us to take a look at the ipconfig-all command. And so the ipconfig-all command is going to show us all of the configuration, the IP configuration information that we need. If there were DNS servers, DHCP servers, and we can see here that we've got our IP address as well as the subnet mask. And so let me pull up, where's desk scribble? There we go. So as you can see, we've got, here's our IP address, and that is a little too thick. So we're going to drop that down a little bit. All right, so this is our IP address, our IPv4 address, I should say, to be accurate. And here's our subnet mask, 255.255.225.224. So if you remember, with a subnet mask of .224 in the last octet, we basically have a class A address. So it's a class A address because it's a 10. And we'll say .x.x.x for right now, and it's a /224. So we need to calculate the value of this so we can determine what that subnet is going to look like. So remember, there are 8 bits in the last octet, or the last byte. So we would say 1, 2, 3, 4, 5, 6, 7, and 8. And the values are 128 and 64, 32, 16, 8, 4, 2, and 1. And so 224 is going to be 128 and 64, and that's 192, and then 32. So our subnet mask, if I were to write the whole thing out, we know that the first 3 octets, 2, 3, 4, 5, 6, 7, 8, dot, 1, 2, 3, 4, 5, 6, 7, 8, dot, 1, 2, 3, 4, 5, 6, 7, 8, dot, and then this is where we're going to do the subnet part. And so as you can see here, these 3 bits are going to be borrowed, and this is going to turn out to be part of our subnet. So we're going to say 1, 2, 3, and then 1, 2, 3, 4, 5. So from looking at this, we can tell that we have 5 host bits and 3 subnet bits, right? So the 5 host bits are what we're curious about. So to figure out the number of hosts, it's 2 to the 5 minus 2. Keeping in mind that that minus 2 is going to be for your subnet ID and your broadcast address. So 2 to the 5 would be 32, if I'm not mistaken. So let's make sure we get that right. So 2, 4, 8, or 16, 2, 1, 2, 3, 4, 32, 1, 2, 3, 4, 5. Yes. So 2 to the 5 is going to be 32, and then minus 2 is 30. So we could have a maximum of 30 assignable host IP addresses, right? Okay, so we also know that if we can have 30 IPs and the block size is 32, our subnets are going to look like this: 0 to 31, 32 to, whoops, I want to change the color there, to 63, and then we're going to have 64, and then 96 would be the next one, so we'll say to 95 is our broadcast address. And then 32 to that is going to be 128, is that correct? Yep, 128, so this would be 127, and then it goes on, so we'll end up here at 159. So from taking a look at the output that we have over here, we can see that this is the subnet into which PC1 falls, right, or the PC that we're looking at here. Okay, so let's keep that in mind as we move on. So back to the exercise at hand. Let me clear off that and then go back to the cursor. Okay, so we've looked at the addressing information. Let's go take a look at the addressing table to see if it matches, right? So PC1, it's pretty much empty here. We would fill in this information and then move on. So now it says click PC3, and we're going to take a look at the same information. Keeping in mind that PC1 is located over here on this 10.10.196/27. So let's come over here to PC3, which is 10.10.116/28. So we'll move that into the upper corner. We'll go ahead and take a command prompt. Let's make this a little larger here. And so we'll type in ipconfig, whoops, and we're going to do ipconfig -all. Okay, so there's our information here. So this, unlike the previous example, and I'll put a line through here, and let's actually change our color. We'll go to this color here. Okay. So for this example, the subnet mask is 225.225.255.255.240. And so 240 is going to be in binary 1, 1, 1, 1, 1. So it would have basically been, we just add this next bit to 224, that's going to give us 240. So then 1, 2, 3, and 4. So now we have 4 host bits, right? So we've got 2 to the 4 minus 2 possible assignable host IPs. So it's going to be 14 assignable host IPs. And again, the block size would be 16. So the subnets would look like 0, 15, 16, and then you could just do 32, 48, 64, 80, 96, and so forth. 31, 47. These are the broadcast addresses I'm filling in now. Oops, I'm going to go 79, 95. And so our IP is 10.10.118, so we fall right into this subnet right here. So the broadcast address should be 31, and the subnet ID should be 16. And as you can see, the default gateway has been assigned the first usable or assignable host IP in the range, and that's .17. Okay, so we're good there. We've taken a look at this information. See what our next step's asking for. So collect all the information and then test connectivity between PC1 and PC3. So let's go ahead and ping PC1. So that's going to be 10.10. Let me take a quick peek over here again. 10.10.190. Trying to remember. 98. Let's pull it back up here real quick. 10.10.198. All right, so we're going to ping 10.10.1.98, and it said that they should fail, and they do. We get a destination host unreachable. And then the request times out, so none of the pings worked. All right, locate the source of connectivity failure. So from PC1, enter the necessary command to trace the route to PC3. So let's come over to PC1, and we're going to pull the command prompt up again. And this time we're going to make it just a little larger here. Okay, so I would say trace RT, and we're going to go over to PC3, which is 10.10.1.18. And so as you can see, I hit the first hop, which is going to be 10.10.1.97. We'll scoot this over here. So I hit 10.10.197, and then I hit 10.10.197 again. Then the request times out, then it hits 10.10.197. So as you can see, we're repeatedly hitting the same IP address which is the default gateway address on PC1. And so we've definitely got something wrong here. Let's do a little more digging to see if we can figure out what that might be. So we just did step 1, or step A under step 2. We tried to trace route to PC3. Was the last successful IPv4 address that was reached. It was our default gateway address, right? So you can see it's looping here. So we're hitting the default gateway, then it's timing out. Then we hit the default gateway, and then it times out. So the trace will eventually end after 30 attempts. You can enter Control-C to stop the trace before 30 attempts, which we're going to go ahead and do right now. All right, so click R1 and then the CLI tab. So let's jump onto router R1. And we're going to take a look at the CLI tab. And we're going to enlarge the size here. So we'll hit enter a few times. So it says enter the show IP interface brief command. Let's go from user exec into privilege exec. So show IP interface brief. And so here are the interfaces we currently have. You can see that Gigabit Ethernet 01, which is in fact 10.10.197, is in an up and up state. Okay, so from there, it's asking us to do the next step. Okay, so from PC3, enter the trace commands. And we actually skipped a command here. So from PC3, let me take a step back real quick here. Let's pull PC3 up, and they want us to trace from PC3 over to PC1. So if I was to type trace RT 10.10.1. Or I'm sorry, .1.98. And you can see that we get the first hop to the default gateway and the second hop to the default gateway. And then we get the request timeout. And so this is going to look very similar to what we just saw on host PC1. All right, so I'll let it request timeout here so that you can see it's basically looping around. So there we go. Okay, so we got the same results. So now let's jump back onto router 1 here. So it's asking us, says click R1, the CLI tab, press enter. So the show IP interface brief command. So we're looking at the interfaces and their status. So there are 2 IPv4 addresses on the router. One should have been recorded in step 2A. What is the other? So the other is the serial address, which is 10.10.1.6, and that's for the point-to-point link, serial link between R1 and R2. Now, step G, or sub-step G under step 2, says enter the show IP route command. So if I type in show IP route, you can see that we have a number of routes listed here, right? It shows us the directly connected as well as the local entry for those routes. So, step G is saying list the networks to which the router is connected. Note that there are 2 networks connected to the serial 001 interface. Why? So again, we're seeing the connected entry, and then we're also seeing the local entry, right? And that's what the C and the L stand for. So repeat step 2E to 2G with router 3. So let's take a look at router 3. We'll go to the CLI tab, and we'll extend this out. So I'll do from user exec into privilege exec, show IP interface brief. And you can see here we also have 2 interfaces assigned. One that is on the point-to-point serial link to router 2, and then an IPv4 address that is the default gateway address for PC3 that goes through switch 3. So we see that same information here. It says notice how the serial interface for R3 changes, right? So it's a different IP address for R3. So run more tests. If it helps to visualize the problem, simulation mode is available. And so you can see down here, you have the real-time tab, but if you click here, you have the simulation tab. And so the simulation tab can be used to send or to simulate traffic going across the network. So as you can see here, we had the ICMP, right, at PC1, okay? And so I can reset the simulation, right? You have play control, so you can go capture forward, so it's actually sending the packets now, and you can see the packets making their way through. I could say back to bring them back, and there's some filters here that you can use as well. So now let's change back to real-time mode. Alright, so here we are back in real-time mode. So it said run more tests if it helps to visualize the problem, and then it recommends, or it says you can use simulation mode. So step 3, propose a solution to solve the problem. So we've looked at router 1 and we've looked at router 3. So now let's take a look at this router in the middle here, router 2. And let's see what router 2 is doing. So we'll go from user exec into global config. And then we're going to say we're going to go ahead and say show IP interface brief. And so there are the two interfaces, both serial interfaces, 10.10.1.2 and 10.10.1.9. And then we can also take a look at the show IP route to see what we see for route. So it looks like there's an EIGRP route that's being learned on router 2. And the way that you can tell that is by this entry right here. And one of the dead giveaways is the D. And if you refer back up here to the codes, it shows you it's EIGRP. And we also see the very well-known administrative distance for EIGRP, which is 90. And that shows that it's learning this route for 10.10.1.16/28 via 10.10.1.10. And so what it's saying here is to get to this network, you need to go out this interface, which has that IP address on it. So if we scroll up a little bit, right, the next hop, this is 10.10.1.9, and it's on that serial interface right here, and 10.10.1.10 showed up over here. So let's take a look at router 3 again. So there's 10.10.1.10. So as you can see, we know that the subnet ID is .8, it's a /30, so there's only two usable IPs, which will be .9 and .10. So we go back over here to router 2, and you can see that we're using .9. All right, so it says propose a solution to solve the problem. Compare your answers in step 2 to the documentation you have available for the network. What is the error? What solution would you propose to correct the problem? And so then we've taken a look at some of the subnet information. Let's go back and look one more time. So here is router R1, and it has a connected route, and it also has a local route. But when things come into this router, if the gateway of last resort is not set, there's no default route that's been configured. If it's not for one of these networks that R1 knows about right now, then there's no chance that that traffic is going to make it across those links. And so if I'm on R1, let me see if I can ping over to 10.10.1.18. So I'm trying to ping from router R1 over to this segment over here. And specifically this segment over here that I don't know about, right? Because you'll see I've got routes for 10.10.1.4/30 and 10.10.1.96/27, yet no gateway of last resort. So let's go ahead and set the gateway of last resort. And I'm going to go ahead and set it to the serial 001 interface. So we're going to say, we're going to go to global config mode. I'm going to say IP route 0.0.0.0, 0.0.0.0. And if you do a question mark, you can see you can set it to the interface. So we'll say serial 0/0/1, right? So it says default route without gateway, if not a point-to-point interface, may impact performance, which is true, but this is a point-to-point interface. There's only two things connected here, router 1 and router 2. So we're not worried about performance. So let me go ahead and I can pull that out, and I believe they may be looking for, so we'll say no IP route, and we'll bring it back up. And after the serial interface, if I put a question mark, you can see we can put a distance. But I believe what we're going to do here is we're going to go ahead and put in the IP address on the other side, 10.10.1 for router 2. I believe it was 6. And let's check that out. 10.10.1.4. All right, so now you can kind of start to see the problem. So here we have an IP 10.10.1.2. However, the subnet here is 10.10.1.4. So, and I'm looking at the output here that it's giving me. Yeah, on the serial interface. So as you can see, if it's 10.10.1.4, right, is it even possible, and where's that show IP intercept, in show IP interface brief. So is it even possible to be .6, right? So the two assignable IPs in that subnet are .5 and .6. However, on router 2's interface, when we take a look at that, it is not .5, it's .2. And so real quickly over here to explain, right? So we have a /30, and these are very common on point-to-point links. So a /30 is basically going to be .0 to .3, .4, and this is the subnet that we're looking at right here, right? 10.10.1.4/30. The two usables will be 5 and 6, and then the broadcast is 7, right? So this is the subnet that router 2 has its serial interface configured for, and this is the subnet that router 1 is configured for. And so these are different subnets, and therefore these IPs, which would be .1 and .2, right, if the other side of the link is configured with .5 and .6, which we are, they will not be able to communicate with each other, right? Because they need to be in the same subnet. So let's go ahead and jump on router 2 here real quick. And let's do a show run, and you can take a look at the serial interface, and there it is. You can see that it's serial 000, and it's a /30, and the IP is 10.10.1.2. So we're going to go into global config mode. I'm going to say int serial 000. We're going to say no. I'm going to put this command in here. No IP address. And we're going to paste it, and then we're going to say IP address 10.10.1. And we're 6 on our side, so we're going to say 5, 255, 255, 255, 252. Aha! So now, immediately upon doing that, we have a new neighbor relationship on serial 000. So as you can see, the IP address here was wrong on router 2. Okay, so if I were to go ahead and do a do show IP route now, you can see that I've actually learned about another network, and it looks like we're learning this via this IP, and we know that 10.10.1.6 is router 1 right here. So again, it may be that the default route isn't even needed. So if I do a do show IP route, let's see what we've got now. Aha! So now I have multiple entries here. So maybe the default route is needed, maybe it's not. So now I know how to get to 10.10.1.8/30, and I've picked up this route right here to get to 10.10.1.16. So if I'm on PC1 now, what happens if I ping 10.10.1.18? And look at that, the problem has been solved. So the fact that we didn't have a default gateway was okay because we've learned about that specific route. And the problem was solving what was taking place, the IP address here on router 2. All right, so implement the plan. We did that. Let's come down to step 5, verify from PC1 to PC3. And then from PC3, we're going to go back over to PC1. So if I ping 10.10.1.98. And if it worked one way, chances are it's going to work the other way, and it does, so we're looking good. Okay, so that's our IPv4 connectivity test. Let's take a look at IPv6 here. So now it says use IPv6 config and ping to verify connectivity. So we're going to look at PC2, and let's make this a little larger here. And we're going to say, whoops, go to the desktop tab, and it wants us to pull up the command prompt. And so we're going to type in IPv6 config-all, and this is going to give us our IPv6 information. So as you can see here, we've got our physical address, and this is the MAC address on this PC. We have our link local address here, right, which is definitely looks like it's using the EUI64, because we see the FFFE in the middle of what used to be the MAC, and the 7th bit was flipped, and that's why the 7th bit sits in here. And so real quickly to talk about this, so what's happening here is, if you remember, so the MAC address is 0, 0. We'll take a look at the first couple of hex characters, echo 0. So to convert the MAC, and I might as well write it all out, B035 dot 8, oops, sorry about that, dot 82 Baker 8, right? So if this is our MAC address on the PC, to convert this to a link local address automatically using EUI64, what happens is that you go halfway through the MAC and you insert FF:FE. However, prior to doing that, we need to find the 7th bit. So we know that hex, this will change to 0000 when you convert, when you convert from hex to binary, and we're going to go 0000, and we find the 7th bit, right? So 1, 2, 3, 4, 5, 6, 7, and you flip this bit to be a 1. And so remember, from binary, 2 to the 0 is 1, 2 to the 1, which is that position there that we're going to flip, becomes 2. So the MAC address would then be 0, I'm sorry, not the MAC address. The MAC address would be converted into your link local IPv6 address. So, and let me actually back that up a step. And I wanted to erase that, so just get rid of this guy. So we're going to be FE80 colon, and they've got 2 colons here, so they're dropping the zeros that intercede. And then we've got the MAC address, which is going to be 2 echo 0 colon Baker 0 Fox Fox colon Fox echo, and so there's the addition of the Fox 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 echo 35 colon 82 Baker 8. Oops, I'm running out of 82 Baker 8. And so again, so this would represent, remember, these are hextets, so we've got 1, 2, 3, 4, 5 hextets represented. So there are basically just 4 zeros in here. We've eliminated those 4 zeros in that single hextet. So that gives us 6 hextets. And are there more zeros, or should there be more zeros here? So remember, 16 times 6, if we're saying we have 6 hextets, 1, 2, 3, 4, 5, 6, 16 times 6 is only 96. So there's probably another set of zeros in there, right, to give us 128 bits, because 16 times 7 is 128. Or actually, 42, I'm wrong. 16 times 7, 42, carrier 4, 112. So we've got another set of zeros in there, right? So now we've got FE80 colon, and what would be in there if you were to expand this out would be our 8th set of zeros to give us 16 times 8, which is going to be 48, carry my 4, and there's my 128, right? So this gets added to the front of the address, FE80 colon 0000 colon 0000 colon 000, and we collapse that down to just FE80 colon colon, right? And then we pick up with the MAC address, we get halfway through the MAC, and we drop in the FF colon FE, and then we finish the MAC out. And so that's your EUI64 format. That's how that link local is being automatically generated. Okay, so we've got some IPv6 information here on the PC, and then what is it asking for us to do next? To complete the addressing table, and so then click on PC4. So we're going to take a look at PC4 here, and we're going to do the same thing. So bring PC4 down here, make this a little larger. Go to the desktop tab, and we're going to type in IPv6 config, IPv6 config -all. So then here's our information, and here is our global unicast IP, and there's our default gateway. FE80::2, the default gateway over here is FE80::1, right? Okay, so we'll come back up here. It says test connectivity between PC2 and PC4. It says it should fail. So I'm going to go ahead and say ping, and between PC2 and PC4, let me drop this down just a little bit here. Actually, we'll just move this guy over. And let me take a quick look here again. Actually, we're going to cut and paste. So we're going to ping that address there. So I'm going to copy that. That's PC4's address, so we're going to say ping, and I'm going to paste that in there. Request could not find host. Please check the name and try again. So again, we're pinging, and I've got the subnet mask on there, so we're going to take that off. So we're pinging and we're timing out, right? And again, we would expect that this is going to fail. And so I'm going to grab this IP here, trying not to grab the subnet mask this time. Let's see if I can do this quick enough here. So we'll copy that, we'll come over here and we'll say ping, and we're going to type in the IP. And this is going to fail. Okay. So from PC2, enter the necessary command to trace the route to PC4. What is the last successful IPv6 address that was reached? So on PC2, we're going to type in traceRT. And as you can see, we make it to our default gateway. Lower that down a little bit. So we hit the default gateway. We then hit 2::1, which is going to be, should be right in here. We get to 1:3::2, which should be here, but then we don't get any further. All right. So we did make it across a couple of the routers. Let's try the opposite direction. Let's trace route the other way. So traceRT. And this guy looks like he's struggling as well. Okay, so let's pull up router 3 here. And we're going to go from user exec into privilege exec. And we are going to type in the show IPv6 interface brief command. And you can see that the gig00 interface is up and up. Gigabit Ethernet 01 is up and up, and serial 001 on router 3 is up and up. All right, and VLAN 1 is administratively down, so it looks like VLAN 1 has been shut down with the shutdown command. So if we type in show run here, let's see what information we see. So there's some EIGRP information, and you can see there's IPv6 router EIGRP1 with a no shutdown command in there. So you've got this IPv6 EIGRP setup in here. So let's type in show IPv6 route. Right, so here are the IPv6 routes. You can see we've learned a couple from EIGRP. We're learning about the 2001 DB8:11 and the :12 subnets. And :11 is over here, and :12 is right in here, and this is :13, to which we are directly connected, right? Okay, so it has us look at router 3, and then we enter the show IP brief. It says run more tests if it helps, or some simulation. So let's take a look. If we remember correctly, the IP address between router 3, if we do a show run, all right, so we're good there. Serial 001 is 10.10.110, and the IP address, let me slide this over, is 2001 DB8, the IPv6 anyway, and IPv6 EIGRP1. So let's take a look at router 2. See what router 2 has on it. So show run, and we're interested in the setup between these two routers to see are those serial links set up properly. So 10.10.110, 10.10.19 for IPv4, the link local FE80::2, FE80::3, right? For 2 representing router 2, 3 representing router 3. The global prefix, or the global unicast IP is 2001 DB8:1:3:1. And over here it's 2008 DB8:1:3:2. So that checks out. And then we've got IPv6 EIGRP1. So we've got the EIGRP process running on the interface, so we're good there. And remember, we had to make this change here. We had to change this guy. But down here with the IPv6 address, you'll notice that it's just simply 2001:1, right? So let's take a step back and let's look at router 1. And let's see what router 1, how router 1 is configured. So if we do a show run on router 1, you've got FE80::1 for our link local on the gig 00, but we're interested in these serial links here. So serial 001, and it's 10.10.16, which is correct. And these guys are definitely in the same subnet, right? The :2::1. But let's pull this up here, because here we're showing that it's 2001 DB8:1:2, and then we're ::2, even though this is router 1, that's okay, right? And so let's do a show IPv6 route. Whoops. Show IPv6 route. And let's see the routes that we know about. So we know about the 3 subnet, and then we've got an entry here for :1:4/64, so we'll slide to the side a little bit. So we do know about this network over here, and this is where PC4 is at. So if we go back to PC2, and I do a show IPv6 route, do we know about 4? We do, and we're learning it via EIGRP. So it looks like we've got the routes that are necessary between router 1, router 2, and then if we look on router 3, that's directly connected. So if I do a show IPv6 route, we should see that it's local and it's also connected, right? So we have the routes across to the other side, and if you remember, when we ran our ping command, and I was pinging PC, let me see which PC we have in here, 2001-1, so this is going to ping back to PC2. So you can see there, it works from PC2. So let me go over to router 2. Can I ping PC2 from router 2? And we'll paste it in, and it works. And how about from router 3? Whoops. All right, so I can ping from PC3 all the way over here to router 2. Let me go ahead and get PC4's IP address here, and this is still running. So let me get the IPv6 address here for the host. And then let's come over to router 3 and try to ping that address. And that works. And let's try router 2. Aha! So when trying to ping from router 2, we're not getting there. Which means if I try to ping from router 1, I should also not get there. All right, so working our way backwards from PC4, we started here at router 3, and we were able to ping OK. But then router 2 cannot ping PC4. So let's go ahead. So router 2 could be either the root cause, right, or a contributing factor. So let's go ahead and take a look here at the show run, and I want to see specifically, I'm interested in those serial interfaces, and most notably the serial interface between router 2 and router 3. And so there you can see we've got the IPv6 address on the serial 001 interface, DB8:1:3, so we're in the right subnet, ::1. And then over here, if I do a show run and we take a look at serial 001, it's 2001 DB8:1:3:2/64. So that's also correct. The link locals are correct. And let's see here. So what are we missing? We've got the IPv6 EIGRP1 on the interface. So there's our IPv4 configuration that's not impacting. And then we've got this IPv6 router EIGRP1 no shutdown command. So let's take a look at router 2, and you can see it also has that same command. So then we'll take a look at router 1, and let's see what router 1 shows us. And it also has that command as well. So that's the global config command, and these are the interface level configuration commands. So back to router 2. These guys are in the same subnet. The link local addresses are good. However, my traffic that comes over to PC4 is not making its way back. I'm sorry, that comes from router 2 to PC4. I'm unable to get there. So let's do a trace from PC2. So if I say trace, and let's put in the IPv6 address, you can see that the first hop that we get is over to router 3, keeping in mind that router 3 on serial 001 is 2001 DB8:1:3:2/64. So we get there, but then that's where the traffic stops. We don't get anything back. All right. So again, I can ping from PC3, and it works great. Can I ping PC2? Let me see if I can ping PC2. 2001:DB8:1:3:2, and I can ping PC2. So let's take a look at PC4. All right, let's see what PC4 has in here. So the default gateway address is FE80::2. So the default gateway for something on another segment on the PC is FE80::2. But if I'm not mistaken, and I could be, I have been before, aha, let me do Control C here, because it's messing things up. Control Shift 6, there we go. So if I do show run, and we come down here to serial 001, so the segment that I share with router 3, I am FE80::2, right? So let's take a look at router 3. Could this be the problem? So where is FE80::2 configured here on router 3? And as you can see, the link local address is FE80::3, and that's out here on serial 001. And so the default gateway address, right, for gig 00, which is, this is the interface for the default gateway, this is also FE80::3, right? That's the link local address. So it turns out that the reason that we can't ping or trace route between these two, it doesn't have anything to do with our subnetting, right? And it certainly isn't that the EIGRP routing protocol isn't working. It's that the link local IP address, FE80::3, on the PC, it's set to FE80::2. So let's go ahead and go into our IP configuration. I'm going to change that to 3. And now, let's go ahead and see. And this worked before, but we're going to make sure we haven't broken anything. So can I ping PC4? I can. Let's jump back over here. Can I ping PC4? And actually, I think it should be in there. See if I can trace to it. Look at that. Trace worked magnificently. Can I ping it? And the ping works. So now if I come all the way over here to router 1, the ping should work again. And it does. And then finally, our final test is PC2 to say ping. Whoops. Can we ping PC4? We can. It works great. And what if I were to do a trace RT over to PC4? Working beautifully. All right. So what it came down to was being able to identify inside of the configurations where we had some misconfiguration due to subnetting, right? Where the addresses that were on this serial link did not fall within this subnet, or one of them did not fall within that subnet. So we sorted that out. Our EIGRP adjacency, neighbor adjacency established. We picked up the routes, and that problem was solved. And then the final issue, which was, again, we could have changed the link local address on router 3. That was one option, right? We could have changed that link local address right there, but I decided to take the easy way out, or I shouldn't say the easy way out, but one of the ways to resolve the issue, and that was to change the link local address here. And if you look at our points total, we're 20 out of 20, so this is actually, they were looking for you. Let me see if they, and it's not even giving you, that's nice. So it's not even telling you how they were wanting you to fix that. So there were some options there that you could have done. So we could change this to :2, right? So if I were to go back in here, I could change this back to :2, right? And close it. And so if I bring the command prompt up now and I try to ping 2001:DB8:1:1:2, I believe it is. Actually, I can't remember the PC2. Let me slide this over here. The PC2 IP, or actually from PC2, if we try to trace now, right, it should stop. It should do what it did the first time. So before we fix that default gateway, and there you go, it's broken again. So I changed the link local address on PC4 and it's broken it. Now we could have just changed this back to :3 and we'd be done. However, I'm trying to see if the alternative method is going to work as well. So gig 00, I'm going to lead in, we're going to clean this up here. So I'm going to say copy. So we're going to go into global config mode and then into interface gigabit Ethernet 00. I'm going to say no IPv6 address link local. Then I'm going to say IPv6 address FE80::2 link local. And now let's see if that has resolved the issue. And it has, right? So the key was making sure that the default gateway for PC4 was actually what that link local IP address was, the IPv6 address here on router 3. And again, there were two ways we could have fixed this. And we chose to go ahead and tweak the default gateway statement here on the client, PC4, but we could have just as easily changed the IP address configuration on router 3, that link local here. My personal preference would be to say, and you'll notice we did not get the points, right? So, because my personal preference would be leave that as :3, right? So let's pull this back. I'm going to do Control A. I'm going to say no, and then we're going to pull the one up. And I would leave it as 3 because it's router 3, right? Easier to identify. So we'll change that. Close this window out. If I pull this client back up here, PC4, and change him to :3. All right, now the default gateways match, and PC2 is going to be happy. Whoops. Let me click in here. PC2 is going to be happy, and that trace is going to succeed. All right. So this has been PacketTracer tutorial 8.3.2.6, and I love the troubleshooting tutorials. They're absolutely fantastic, and I know they can be frustrating sometimes, but it certainly gives you some great exposure to utilizing the tools that you've been slowly but surely accumulating in your networking tool chest for troubleshooting. Specifically here, IPv6 config-all, IP config-all, ping, and traceroute. All right, so this wraps up our video tutorial for the day, and have a great day.